Right, okay, I'm just going to tell you a little bit about what we do in the Floow in this area. It's not everything that we do, I'm just going to tell you about some of the future mobility and new mobility stuff that we're doing. We're one of many mobility tech companies based in Sheffield, so we're just one of many, and I was just going to tell you a little bit about what we're doing in this area, work that we've had in the city itself, and also what we're trying to do more of that we would love to happen here. So, for those that don't know us, just a 2-second introduction quickly. We're a fast scale-up company based in Sheffield. We've got offices in the US and China and elsewhere as well. But, we're about 120 people and we build solutions based on telematics. We monitor vehicles as they move to understand their risks. We mainly work for the insurance industry. So we gather data, a whole variety of different technologies. I won't go into them in detail. If anyone really wants to know anything about it, ask me afterwards. But as part of that, we do gather from a lot of future vehicles as well, and a lot of new vehicle propositions, not of mobility as a service, a lot of shared vehicle usage, and how it interacts with everyone else as citizens is all a big part of what we do. So what we do is we try to gather this information to give pictures of how we understand locational behaviour. This is animated, you can't see a thing, but anyway. What you end up getting is a picture of how mobility fits in a particular location. This is one of the things that we really try to focus upon and use that data to help power other services or help improve other services or understanding of the transport network itself. And we do that all over the place. We do it for lots of different people. We work with a whole variety of universities. You'll notice two Sheffield ones there. We're also working directly with government departments, including Department of Transport, Centre for Connected Autonomous Vehicles, various other departments, also the Law Commission for setting new laws related to mobility insurance, how those laws are changing around new modes of transport. Work with industries, lots of them, to look at these new solutions and how they're changing and how they're going to be deployed, and a whole load of OEMs. So OEMs are the vehicle manufacturers, an awful lot of these that we end up working with. And we do that in order to actually work out how are things changing, what are they changing, what data can we share from one platform to another to help make things better for everybody. So we kind of sit between a lot of different organisations. People know us for talking to motor insurers and possibly OEMs, but actually we sit between a whole lot of other organisations as well. Ranging from infrastructure companies, tier 1 suppliers that supply the automotive market, government and public bodies for the data that we have about place and how they're used, fleets, and a whole series of car service things and organisations. But what I was focusing on today is just to tell you a little bit about some of the R&D stuff that we do more in the autonomous and future mobility. So that's just really where I wanted to focus. So to start that, just thought I'd introduce some of our early work in this area. Again, there's an animation you can barely see, but if anyone has a distinct desire to look at it later, I can show you. This was gathering data in Sheffield, working with Mila's department actually over there, which is a first kind of attempt looking at autonomous based in Sheffield. So this was gathering data on Sheffield roads using cameras and instrumented vehicles, which all went very well until the vehicles got stolen, but other than that. We gathered a lot of data that told us about the streets of Sheffield, how they behave. It's not you'll see on every road. These are a few vehicles to gather choice data to be able to make decisions about what sort of data do we need, how can we use this in a way to help improve the network, and what can we do with it. We led on from that to do a whole series of other work, and I'll detail one of them now in terms of a project that's renowned for being in Greenwich, but it was also in Sheffield. This is a Move UK project. So there's we have instrumented vehicles from Jaguar Land Rover that were driving around this city and also up and down the country and everywhere to gather information about how the roads are used, how drivers operate. And in these vehicles we were testing autonomous technology that's going to go into vehicles in the next 5 years. New sensor technology for cameras, new sensor technology for radar. You can't see it, it looks like a normal car, and that's by design. These things peel off so you don't actually see it looking like a car that would mean you drive differently around it. The prime basis of this is to gather information and data on how the roads are actually used, how they behave, how the environment works around them, so we can understand it better and then start to build new products and services. So we do that with a whole series of instrumentation. The vehicles are fitted out with about £250,000 worth of kit. Unfortunately, they've been crushed since, but anyway, that's a different story. I'll tell you about later. But what they've done is use that data to gather an awful lot of capability about what's coming nearer to the market that is going to affect and transform the transport networks that people know now. This is primarily roads, but obviously it interacts with other parts of the network. So there's a lot of technology inside vehicles, as I'm sure you're aware, and I'm sure it's growing tremendously. We were testing new technology within these in terms of video, radar, and surround sensing technology, and how that impacts on the way that people actually drive. What systems are safe to put in those vehicles, how to actually make them actually operate so you don't end up with putting a nice safety feature in there, then people stop looking out the window, so they end up crashing anyway. So it's trying to make things work universally better for everybody. The way that was done was to build up a whole body of data. So this is a picture of Greenwich, not Sheffield, I'm afraid, but we did gather it in Sheffield as well. I just didn't have the video before these slides, I'm afraid. But what we do is we gathered an awful lot of data from multiple passes of the same vehicles again and again and again, being driven by different drivers, different conditions, different purposes, different routes, and seeing what information they're gathering about the network. When do they not see things? When do the vision systems fail, like at night in the rain and in fog and so on? When do the systems work well? When does it not work? When someone's parked over a curb and actually the line detection and the curb detection will never actually operate because people are just parked on the road, on the pavements where they shouldn't be. So actually, what do you need to change to make systems possible to actually let some of this technology to flourish, to actually change the world in which we live? So building up that data gives a whole series of fields. There's a whole load of text there saying some of the things you pull out of the vehicle. So we get every bit of information coming out all the vehicle sensors, knowing from the level of illumination display that the user's seeing, how high the windows are up to what gear they're in, to how they're operating, behaving, how much they're exact pressing in Newton's force on every pedal and instrument. So we know how people are operating these vehicles and how they change their behaviour under certain conditions. And we're testing those to see what changes in the environment that you can start to see. And there's millions of plots passing through here, lots of analysis. I can't talk about each of them individually, but there's a whole load of things here that tell you interesting patterns of behaviour. I think there's an interesting one coming up at the moment about where people press on the accelerator and the brake at the same time, which is bad behaviour. But anyway, gives you an idea. Oh, there it is. That gives you an idea of where this technology works and where it doesn't work, and how humans really react with it, as opposed to actually what the automotive wants to build, and then they sell you it, but it actually doesn't do what you really want it to do because it has an effect that's different. So using the camera systems out of these vehicles, we start to detect all the things that vehicles are seeing around them. So you start to see the obstacles, you start to see scenarios, and you start to pick up the unique instances that happen and where they happen on the network. So there's a harsh braking event here. This particular trigger is where a certain emergency system would have kicked in order to say, had the driver not done anything themselves? They did do, so it's fine. But the problem is those same technologies do fail in senses that don't help users. So in this particular one, driving on a residential street, you'll notice this lovely plume of smoke coming out the back of the car here being identified nicely as a vehicle, and the vehicle drives straight through it. The safety systems here actually tried to kick in, and it would have actually caused that car to automatically brake. If that was a production system, but obviously this was a modified vehicle, that would have caused an accident with the car if it was being close followed by someone behind it. So how do you actually make that technology safe so it ends up saving someone rather than accidentally killing someone? So a lot of this technology is useful in certain circumstances and not so useful in others. What we focused on was looking at the things that are nearer to market. So we're not building pods, we're not looking at the things that are going to appear in very constrained areas of the road network in the near future. Obviously long-term things may change. What we're looking at is actually how is transport changing in the near term. And there's a lot of technology built into vehicles, from cameras, this is a custom fit one, and radars. But in terms of what you end up seeing out of the vehicle, it actually can lie about actually the safety conditions. They can actually tell you to do things in the vehicle or change the behaviour of the vehicle in a way that you wouldn't want it to happen. So for example, automatic emergency braking, everyone's heard about it, it's a simple example. You see things in front of you, you think that's bad, the vehicle should automatically slow down or stop. actually the road's completely fine. It's just basically looking the wrong way because the sensors are constrained, they look straight ahead, they're fixed, they only look in one area. If you go up a speed bump, you look at the sky, you don't see what's in front of you. You go down a hill, you don't see what's in front of you. So there's lots of technology that doesn't actually work in the real world in the way that roads are designed. So where does it work and where doesn't it work was a big part of the study. And of course, examples where you get the opposite, where it says, yeah, completely fine. Meanwhile, there's something straight in front of you and it doesn't see it. So there's a lot of problems with using parts of these technology and parts of autonomous technology and where it can be deployed. So everyone talks about an operational design domain, where a technology can safely be deployed. And a lot of people talk about, you can put it on motorways, that's fine, but the refresh rates of cameras, particularly in the dark, are actually not fast enough to operate in low light situations at high speed. So there's still some limitations in the speeds that you would go at. So although that technology is improving, there are still some barriers in some of these basic technologies that would allow you to have certain constraints about where this technology would ultimately get deployed. What it can do, however, is it can start to build maps of places for where technology struggles, where safety systems fail, where there are risks with vehicles today and vehicles going onto the road, whereby you can immediately say exactly and localised where they are. The little bits here that are red, or the bits that are slightly more red than others, are problematic for new safety systems in vehicles, and they do not operate in those areas of the road network. So if you're driving along thinking your safety systems in your vehicle keep you safe, they only operate part of the time. They don't operate all the time. And you can start to map where these things start to occur. That can start to feed back into the design of the infrastructure, or can at least inform that actually the vehicle technology can get better, and how do you make it better? So this is some of the things that we've been involved in these areas, but we're also using the massive data that we've got. We've got the largest source of telematics data in the UK in terms of vehicles moving around. We work for quite a few of the lead insurers in the UK, so we get a lot of data coming in. And it gives us an ability to poll and understand the transport networks. We use this not just to impact in roads, but to also impact active travel, people travelling in other ways, and I'll get onto that in a second if I've got time. So we build up a picture of what behaviour is like. So you get a picture of speed and acceleration for every little section of the road, the thickness of roads there. I think that's Manchester, I can't remember where. It gives you an idea of the amount of traffic. But the speed profiles you get in different locations tell you something very particular. Now, most people believe that traffic is the same everywhere. Okay, you go to a different country and they drive different. But actually, it's much more refined than that, that you get very different behaviours from one city to the next. So in London, all these areas of red are where people are having extreme aggression and moments, whereby which is basically the whole of London. But not the arterial roads, the white ones, where people are watching them with cameras. They're very, very reserved there. Sheffield, very different behaviour. You get all the very excessive behaviour happening only on the key junctions. Glasgow, completely counterintuitively to common sense, you only get it occurring on the ring road where it's being monitored. No one understands why. But you get a lot of very different localised driving dialects. And you can use this information to understand the networks that are actually there, where they're safe, where they're not safe, where it's into causing traffic to behave in a certain way that's increasing pollution or decreasing public safety. So as an example, this is somewhere in Birmingham, the Edgbaston Stadium. There's an area that's red here, which is basically an area of volatility. So the volatility only in weekday AMs on that particular section of road is elevated compared to the rest of the surrounding area. And usually there's good reasons for that. You can start to look at it on the transport network and go, hey, there's something wrong, or it's just where people are jumping the lights or whatever. But you start to get areas that are harder to explain. So in this particular one, it's a nice, well-managed road, separate lanes, you get separate lane control to go different ways, traffic lights and so on. The reason was that set of lights is not in sync with that set of lights at certain times of the day only. So you can build it up just from the evidence pattern of how traffic's behaving to see where those issues occur and start to use it to refine and actually make the transport network safer. So you can do, doesn't happen all the time though, weekends, no problem at all, anywhere. So you can start to do that and across large stretches of the transport network. So a traditional method of understanding transport, you'd put a road centre here, road centre there. You get a few dotted around and try to use that as a pole to understand. But using this type of data, you can actually completely look at every individual road of the behaviour looking back over time and look at the statistics of how it's being used to help inform policy and help inform changes. So we're doing a lot of this now to use this information to improve active travel and to improve livable neighbourhoods. So at the moment, a lot of this data is being used across the east end of London, Southampton, Lambeth, parts of Manchester and a few other places to try and feed information into how you make neighbourhoods better. So you can start to say for an individual road that you're going down, 70% of the traffic is not even from the region, shouldn't even be in the region, they're just using it as a shortcut. So you can start to then use that as a policy driver to actually say, actually, let's cut this street off, let's just make it for local people, make it for residents, and drive people down this other alternative route. You can use it as an evidence base to make some changes. Of course, we use all this, and particularly the vehicle volatility, to feed into a lot of autonomous programs as well. And we also look at individual junctions. This particular road is somewhere near Norfolk, but it's at this particular stretch, which is only about 500 metres long, kills 5 people a year. It's one of the kind of red roads of England, and there's been about 200-300 interventions since the 1970s, on that particular road, and never really had any improvements. But when you start to look at the behaviours, you can start to see at the individual junctions where the problems are. If you start correlating it to accident data, it all happens at certain times of the day, and you can start to see why. But there was no data before being able to get that to determine what the cause was. The real cause is people just go straight past it. It's a long straight road and they don't turn off because everyone's going straight. So basically it's quite risky for the people coming in or going out of that particular junction. Most of the time of the day, it's 2% or 4% of the traffic turning from route F to route D, whichever one it is, going down this particular way. But at certain times of the day, 22% of the traffic is making these these turns. At those instances, you end up with very slow traffic coming down, and it's just around this corner, out of sight, when you come down. You can see immediately the evidence base that points to actually there's the road safety issue. And all you've got to do is put a slow down sign, and it will save lives. So there's quite a lot of things you can start to use the data for. We're using that information to feed into autonomous programs to actually get them to understand where is safe for vehicles to travel. And one project we're doing at the moment, which is again London-based, is deploying robo-taxis, which have just gone on the streets now. So I think there's probably been news about it in the last week or so, but these have now been deployed and starting picking up drivers, travelling around London and taking them from one location to another. I think it's somewhere between Bromley and Croydon for some unknown reason. But what we're doing with this is actually we're setting the routes deliberately to be as safe as possible for the times of operation, because we can understand where is safe, so that we can actually pre-calculate the insurance and that actually everything operates smoothly enough that everything can be underwritten and everyone knows it's a safe enough system to put out before it's even gone on the road. So these are some of the things that we're doing. Obviously, there's a lot more, and I've got not much time, and I've run out of 10 minutes, but if anyone wants to talk to me later, please do. And if anyone wants to get in touch, again, do. But big message is, I want to do more of this in Sheffield, and can we work together to do something here?